Today we are going to learn about linear programming problems. Let's look at a problem. Solve, minimize c is equal to negative 8x minus 5y subject to the constraints y greater than equal to 2x minus 2, x greater than equal to negative 2, y less than equal to 1. Now for these type of problems, when we want to minimize c, we will graph these constraints first of all. Let me take them as equality. I can say y is equal to 2x minus 2. Comparing this with the slope-intercept form, slope-intercept form is y is equal to mx plus b, where m is the slope and b is the y-intercept. So we get b as negative 2 and m is slope, that is 2. We can write 2 as 2 over 1, or this can also be written as negative 2 over negative 1. Now why we write this is because slope is change in y over change in x. We can take change in y to be 2 units and change in x to be 1 unit, or we can also take change in y to be minus 2 units and change in x to be negative 1 units. So we will use the slope-intercept form in order to graph this equation. So let's see, our y-intercept is negative 2, so it will be here. Now 2 units up on the y-axis and 1 unit to the right, and 1 point can be taken 2 units down on the y-axis and 1 point on the left hand side. So by joining these 3 points together, I can get the equation of the line, graph of the line. So this is the graph of the equation y is equal to 2x minus 2. Graph of the line 2x minus 2. The other inequality is x greater than equal to negative 2 means x is equal to negative 2, y less than equal to 1. So y is equal to 1. Now let us first plot these. X is equal to negative 2. It will be a vertical line on the point negative 2 on the x-axis. This is negative 2. So this is the line x is equal to negative 2. And we have y is equal to 1. This is the point 1 on y-axis. So line passing through this point. This is the graph of the line y is equal to 1. Now these lines, these graphs, or the graph of these lines are meeting at these points. These are known as corner points or also known as boundary points. The solution region will lie inside this triangle because, let's test the region first of all. Let me take 0, 0 as the point and I'll put it in y greater than equal to 2x minus 2. 0 greater than equal to 2 times 0 minus 2. 0 greater than equal to minus 2, which is true. So the solution lies above this line which contains the point 0, 0. X greater than equal to negative 2 means all values are either greater or equal to negative 2. Solution region lies in this way. And y less than equal to 1 means all the values which are less than or equal to 1. So solution lies here. So this triangle is the solution. This point here is given by negative 2, 1. This point here is given by 3 by 2, 1. And this point is given by negative 2, negative 6. So now I get the boundary points and I get the minimum or maximum value at the boundary points. So I'll calculate my C at these boundary points. So I'll make a table like this and write the coordinates here. One is negative 2, 1, 3 by 2, 1, and negative 2, negative 6. And the equation is C is equal to negative 8x minus 5y. Now I'll put first of all negative 2, 1. So C will be minus 8 times minus 2 minus 5 times 1. 16 minus 5, that's 11. Similarly, we can put 3 by 2, 1 and we will get negative 17, and putting negative 2, negative 6 will give us 46 as the C value. Now we need the minimum C value. So minimum C value will be negative 17, which occurs at 3 by 2, 1. So B negative 17 is the answer. Next problem. Solve. Maximize C is equal to negative 8x minus 8y subject to the constraints y greater than equal to minus x minus 2, x less than equal to 1, y less than equal to 0. This means x is equal to 1, this means y is equal to 0. Y is equal to 0 means the x-axis. So y is less than equal to 0 means all values are either less than or equal to 0. So the solution will lie below this line for this y less than equal to 0. X less than equal to 1. So x is equal to 1. Let me first of all, here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10. So this is the point 1. So a straight line passing through this point. So this is the graph of the line x less than equal to 1. X is equal to 1 we can say, and the solution region will be to the left of this line since all the values will be either less than or equal to 1. So we can say solution will be here. Now y greater than equal to negative x negative 2. So y is equal to, I can say minus x minus 2. B becomes my minus 2 and m is minus 1. So I can write this as either minus 1 by 1 or 1 over minus 1. Means change in y is either plus 1 or minus 1. When change in y is minus 1, change in x will be 1. When change in y is 1, change in x will be minus 1. So let us graph this line. B is minus 2 here. So change in y, if I take minus 1, change in x is 1. And change in y plus 1, so change in x minus 1. So join these 3 points. This is the graph of the line y is equal to minus x minus 2. And the solution region, let me put 0, 0, y greater than equal to x minus 2, 0, 0. 0 greater than equal to 0 minus 2. So 0 greater than equal to negative 2, which is true. So solution lies above this line. So this becomes this triangle, this small triangle becomes the solution region. And the boundary points are given by, this is 1, 0. This point here is given by negative 2 comma 0, and this point here is given by 1 comma negative 3. So let us calculate C at these coordinates. C is equal to minus 8x minus 8y, negative 2 comma 0, 1 comma 0 and 1 comma minus 3. So at minus 2 comma 0, my C will be minus 8 times minus 2 minus 8 times 0, which is 16 minus 0, which is 16. Similarly, we can calculate at 1 comma 0, we'll get negative 8 as C, and at 1 comma negative 3 it will be 16. So the maximum value comes out to be 16, which is at the coordinates negative 2, 0 and 1 comma negative 3. So B16 is the answer. Next problem. Solve. Minimize C is equal to negative 3x plus 6y subject to the constraints 0 less than equal to x less than equal to 1 and negative 3 less than equal to y less than equal to 1. So here I can say my x is greater than equal to 0 and my x is less than equal to 1. Y is greater than equal to negative 3. Y is less than equal to 1. This implies x is 0. This implies x is 1. This implies y is negative 3. And this implies y is equal to 1. X is equal to 0 means the y-axis. X is equal to 1. X is equal to 0. X is equal to 1. Y is equal to negative 3. Let me make it on negative 3 only. Above. And y is equal to 1. So this line is x equals 0, x equals 1, y is equal to 1 and y is equal to negative 3. Now the solution reasons. X is greater than equal to 0 to the right hand side. X is less than equal to 1 to the left hand side. Y is greater than equal to negative 3 upwards. Y is less than equal to 1 downwards. So you will find the solution region will be this common region. This point is given by 1 comma 1. This point here is given by 0 comma 1. This point here is given by 0 comma negative 3 and this point is 1 comma negative 3. So we can make the table here. C is equal to negative 3x plus 6y, 0 1, 1 1, 0 minus 3, 1 comma minus 3. So C is equal to negative 3 times 0 plus 6 times 1, that's 6. C is equal to negative 3 times 1 plus 6 times 1, 3. C is equal to negative 3 times 0 plus 6 times negative 3, minus 18. C is equal to negative 3 times 1 plus 6 times negative 3, minus 21. We need to minimize this, so the minimum value I have is negative 21. which is at the coordinate 1, -3. So C -21 is the answer. I hope you can practice more problems on solving linear programming problems now. Thank you for watching. Have a great day. Bye-bye.